Because we have done this in the past. It was part of your final. Casey?
A squared plus B squared, which is C squared.
Yeah, so we're going to be doing a squared plus b squared equals c squared.
Oh, yeah, I remember.
So we are going to be doing more with the Pythagorean theorem than we did before. When we did the Pythagorean theorem before, we were always finding the hypotenuse. Now we are going to be finding one of the legs as well. And we're going to be adding in what we call Pythagorean triples, because Pythagoras decided that it was good to also know triples and have some of those memorized to make things a little bit quicker for you. Yes, there was a guy named Pythagoras. He did exist. He did he? Why do you know that? Now I need to research Pythagoras and see if that's true. I also hate beans, so I understand. All right. So we know a Pythagorean theorem is used to find the missing side of only right triangles. It is imperative that you guys understand this only works if you have a 90-degree angle. If you do not have that 90-degree angle, you cannot use this. So to do the Pythagorean theorem, you do a leg squared plus the leg squared equals the hypotenuse squared.
Hey, can you take this? I redid it, so one problem.
Hey, you two. Cameron does not need to be in the middle of you two yelling at each other. It's probably super annoying to him. Doubtful. So the legs are A and B, so A squared plus B squared equals C squared. You determine the hypotenuse. You determine the hypotenuse based on the side opposite the 90-degree angle. And it's always the longest side. I think so. I'm not able to simplify that super quickly in my head, but I think that looks good. All right, so solve for x. First of all, we need to determine which part is our hypotenuse. So Logan, which number here is our hypotenuse if this here is my 90-degree angle? Which one is my hypotenuse?
Oh, no, 12.
Thank you. So, you're fine. This is my hypotenuse. Or C. So, when we go to set up the equation then, Hayden, what would you tell me to set it up as, if that's my hypotenuse? Perfect. So x squared plus 6 squared equals 12 squared. Could somebody have told me 6 squared plus x squared equals 12 squared? Does it matter the order of the legs? No, the only thing that matters is your hypotenuse. Addition is commutative, so that's why it doesn't matter. So how could I solve for x here? What would you tell me to do next, Cameron?
Subtract 36.
So is x isolated yet? Is x all by itself yet here? No, Devin, what's the inverse of squaring something? So we take the square root. And we know if we take the square root, we have to do our factor tree. So we do a factor tree. Why did I just try to circle 6? Why doesn't she like this thing? This thing is amazing. No. 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 You're not allowed to agree with me.
So I should say
No.
no.
Definitely. That's totally not going to make me any more angry. So 2 times 3 is 6, so I get 6 radical 3. Hello. Okay, you don't need to talk to Logan. I already told you that.
I'm just trying to work.
I know, it's always his fault. I get it. All right. So, what would be my setup for the next one there? What would be the equation you would tell me to write, Ian?
Square root 5 squared.
Okay.
And then plus.
You can go. It's fine. You're fine. You're fine. Me?
No, I said it's like whenever your mom's like you're telling her your story and then she goes on her phone and looks at Facebook. That's what you just basically did.
You know. And then what? Equals?
C squared.
Or x squared in this case, right? Because it's an x. It's the same thing for you. That's fine. But I'm going to put what's up there so nobody else gets confused by this. Okay. Think about what squaring means. What does squaring mean? Like, we know 4 squared is 16, but why is 4 squared 16? What do you do? 4 times 4, right? The same number times the same number. Good job, you two. So this really means square root of 5 times the square root of 5 plus 2 root 10 times 2 root 10 equals x squared. Well, we learned how to do these last week. The square root of 5 times the square root of 5 is the square root of 25. You multiply outside numbers. 2 times 2 is 4. You multiply what's underneath. 10 times 10 is 100. So you get the square root of 25 plus 4 root of 100 equals x squared. What should we try to do next? We should try to simplify it so you can do your factor trees. The square root of 25 is... Good job. The square root of 10 is, or 100 is 10. So 4 times 10 is 40. I am showing a ton of steps here. So bless you. So if you are somebody that doesn't need to show this much work, you do not need to show this much work. But if you are somebody that makes really silly mistakes all the time, you should probably show this work. You know who you are. Please do what is best for you as an individual. Don't be lazy. So I get to 45 equals x squared. Do my factor tree. And I get x equals 3 square root of 5. Every time I see Cheerios, I think of my children because my children eat Cheerios. Like, that's like a snack food I give to them. I'm calling you a baby, is what I just did. But also, I love Cheerios too, so it's okay.
Your kid's almost about a year old.
She'll be a year old on the 2nd, yeah, because that's when I left you guys last year. Isn't that crazy? It's been a very quick year.
It has, like, a
Is
year
it-
ago we had the best teacher ever.
I know, a year ago you lost me as the worst teacher ever into the best teacher ever. I get it. I'm the worst teacher ever.
Mr. Lieber.
I know. I can't compare.
Worst, we just said Mr. Lieber was the best.
I understand. It's because you guys got to do whatever you guys wanted to
He
do.
got 100% on
Okay,
my
there was
test.
like one time that he yelled at our class to be quiet.
And that was it.
I mean, like, he'd be like, guys, like, his thing was, like, it was your...
That was my biggest fear when I came back. I was like, oh, parents are going to be so mad because they're not going to understand why this happened.
he basically, like, if you were talking, he didn't really care because he saw it as if you weren't paying attention, it means you didn't want to learn. So he would teach the people that actually wanted to learn, and the people who didn't, it was their fault if they were like.
And that's not how the school system works, unfortunately. All right, so this is a perpendicular bisector. I know this is a perpendicular bisector because these two sides are congruent. So what kind of triangle is this if these two sides are congruent? What is it?
Equal.
No, you said it.
Isosceles.
It's an isosceles. So if sides, then angles. Therefore, we have two congruent triangles here. So if we have two congruent triangles here, and this is 10, what do these both have to be?
5.
5, because of the isosceles triangle theorem and the perpendicular bisector stuff that's going on there. So you'll notice now we have, you notice now we have a triangle here. Do you see how there's two triangles within like another triangle? And for us, we want to only look at a right triangle. So the whole entire isosceles triangle is not something we can look at. But we can look at just that, that perpendicular bisector down the middle there. So we are going to call that x. So we already know this is 7. We know this is 5 as well. What would you tell me to set up there, Desiree?
I would set up x squared plus 5 squared.
Perfect. I think you guys understand where the hypotenuse is, which is very important because it's really hard to do the Pythagorean theorem if you don't know where the hypotenuse is. It's usually like that, but it's the side opposite the right angle is the better way to look at it. Because sometimes you could sit it on the hypotenuse if you wanted to, and then it would be, you know what I mean, flat. So you got to be careful with that. You know what? So I get 2 radical 6. So look at that and see if you guys have any questions for me there. Okay, the other one is a rectangle. What do you know about opposite sides in a rectangle? They are equal. So this one is 8 and this one is 12. So if we're looking at this specific right triangle here, you'll notice we do know 2 sides there. So Helena, what would you set up there for the Pythagorean theorem?
X squared plus 12 squared equals 8 squared plus 12 squared is x squared.
So why did you change what you said?
Because the hypotenuse.
Yeah, good work.
C equal.
Yeah, I think you got what you were trying to say out a little bit there. But she changed what she was saying. So originally she said like x squared plus 8 squared equals something, and she was like, wait, that does not make sense. She did not say that way, but she corrected herself because opposite the right angle is our hypotenuse. And our hypotenuse always has to be the one that it's equal to. So it's leg squared plus leg squared equals hypotenuse squared. So that was a good catch on her part. Craig, are you doing okay?
Yeah, I guess.
Are you sure?
Yeah.
Come see me if you need me, okay? Bless you. So I get 4 radical 13 equals x. All right. Questions on the Pythagorean theorem before we talk about our wonderful Pythagorean triples? There's this part. Let me see. I forgot to ask you. Smile. How is it without?
Do your teeth feel like slimy ever? Like not anymore. Do you have like a
So it's an Invisalign retainer. Oh, I wish they had those when I was a kid.
Oh, I saw
The nice like metal ones that just go across your face.
that's what mine.
Miss Brady, I have a permanent one because I never wore mine.
I had a permanent one on the bottom of my teeth too.
Yeah.
They like just cemented into my teeth. And then it fell out because of basketball. Somebody like elbowed underneath me while I was going
How
up
did
and I
it-
bit down. Because my teeth all chipped and stuff too, so they had to take it out.
I had one on
All right, a Pythagorean triple is a set of non-zero, meaning it is, so it's a set of three non-zero, not equal to the number 0. Whole numbers. Whole numbers are not negative numbers. They are numbers 1, 2, 3, 4, etc. Right, they are not the negative numbers. Integers include the negatives. So they're non-negative whole numbers there that are not 0, and they are a, b, and c. So such that a squared plus b squared equals c squared. So if you look back to this example here, just before we do this, I would have given you these 3 pieces here and asked you if this was a right triangle, you could do the Pythagorean theorem to test if it's a right triangle, right? You could have done root 5 squared plus 2 root 10 squared equals 3 root 5 squared. And seen if it was a true statement. If it's a true statement, then it's a right triangle. If it's not a true statement, then it's not a right triangle. So you can use the Pythagorean theorem in that way. But if I would have asked you if it's a Pythagorean triple, you would have had to tell me no. Because these are not whole numbers. These are radicals. Do you see that? They must be whole numbers, all of them. So you'll notice we could have said the same thing here. 6 root 3 plus 6 squared equals 12 squared. That would have come out as yes, it would come out as a true statement, but it's not a triple because one of the sides is a radical. Do you guys see that? A triple must only be whole numbers that are not 0. So if we're coming back to this, these are examples of triples. 3, 4, 5. If I do 3 squared, I'm not going to do this all of them, but if I do 3 squared plus 4 squared equals 5 squared, you'll notice that's 9 plus 16 equals 25, which is true. Do you guys see that? You'll notice they're all whole numbers. Is there any common factor that can be pulled out of this? Can you divide it by anything? No, nothing goes into all of them. So that is a triple. Can't be divided out. You are in a perfect triple there. A 5, 12, 13. If you can memorize these, it will make life so much easier. For whatever reason, I memorized the triples and I still know that stuff, but I can't remember half the other stuff I learned from high school. So that is also true. So you'll notice that it satisfies the Pythagorean theorem, and they're all whole numbers that don't have anything else that goes into them. Does everybody understand that? Okay, so let's freeze for a second here. You can also have multiples of triples. These are called a family. The base of the family is the one without the division. So like this is a 3, 4, 5. Do you guys see that? A 6, 8, 12, or a 6, 8, 10 is part of the 3, 4, 5 family. Why would I tell you 6, 8, 10 is part of the 3, 4, 5 family? Who can see why? Yeah.
Because you multiply those by 2.
Yeah, this multiplies 3, 4, 5 by 2. So that's why it's part of the 3, 4, 5 family, because they are multiples of 2 of that. So 10, 24, 26 is multiples of 2 of the 5, 12, 13 family. And you can multiply by other things besides 2. So we could go through all of these, and you could see that. But the important thing to know is that even if they are not the exact base parent of the family, they can have children that are multiples of it. That's not the right name of it, but I'm just calling them their children. So you will notice that these are also triples. So we do not have to use the Pythagorean theorem if we can notice this is a family. The last number is always the hypotenuse. So if you see 5, 13, 17, or 25 as the hypotenuse, like this one is, and you have one of these two legs, you can just tell me automatically what x is. So what would x be here, based on the family? 4, because this is part of the 3, 4, 5 family. So which family is 8, 15 part of? What would the hypotenuse be? Olivia. Yeah, it's an 8, 15, 17. So you don't have to technically do the Pythagorean theorem. I mean, you can. You'll still get the same answer. It's just a little bit more work. Miss Orff teaches the ACT class down the hallway, and she has stated many times that on the ACT, they typically, when they have right triangles, use like Pythagorean triples. Think about the ACT. You guys all took a practice one this year, right? You know it's timed, right? You have 60 minutes for a 60-question test for math. So if you can memorize that this is a triple, instead of doing the Pythagorean theorem, that might save you a minute to be able to do something else on another problem. So she has stated many times that triples tend to be the ones that show up on the test, just because it makes it quicker so that you guys can actually finish the test. Oh, I should say triple. I just put triple. It's not even a word. All right, questions there? So the next part there is asking us to verify right triangles. I believe, I will clarify this today at lunch, but I believe when we ask you guys to verify that this is a right triangle or not, and then I'm going to ask you if it's a triple or not too, I believe that if we set it up, we will always set it up as leg, hypotenuse. Does everybody understand that? So that you guys don't have to figure out what the longest side is. But I will verify that at lunch. I don't see the point of tricking you. And I know it's that way on the quiz on Wednesday when it asks you, or Thursday when it asks you this kind of question. I know it's leg, hypotenuse. But I'll verify that it's always like that as well for you guys. Now, it may not always be that way in life, but I think that's how we do it in this class. So how can we verify that these are right triangles, Katie? What could we do? What tells us something's a right triangle? What theorem? Yeah, so we can just use the Pythagorean theorem. So we have 3 squared plus the root 10 squared equals root 19 squared. So that's 9 plus root 10 times root 10 equals root 19 times root 19. And some of you guys might start seeing shortcuts as we do these problems, and those of you that see them, go ahead and be my guest. If you are not seeing the shortcuts, you probably shouldn't be doing them in the first place. Does that make sense? Because you're probably not understanding what the problem is doing then. I said that we'll typically leave it in the order of least to greatest. Because typically what you would need to do is figure out which one is the biggest number, but I don't see that we're going to trick you. I'm going to verify that at lunch. I wouldn't say that it's always like that, like outside of life, but I think in this classroom I don't think that we'll try to trick you. Because I can see that being hard enough as it is for you guys when you're dealing with radicals. Okay, so then we do our factor tree. So I get 9 plus 10 equals 19. Is that a true or a false statement? True. It is true, so is this a right triangle? Yes, this is a right triangle because that is true. Is this a triple? Can 3 root 10 root 19 be a triple? Part one is fine. It's a right triangle, right? What's the other piece to being a triple?
It has to have the 3 whole numbers.
Are those 3 whole numbers? No, so this is not a triple. It might be a right triangle, but it's not a triple. I know it doesn't ask you that, but I want you guys to understand what a triple is. All right, let's do number 3, and then we're going to skip on to the next one. I think you guys can pretty much do this. So this is A, B, C. So we have 3/7 squared plus 4/7 squared equals 1 squared. No. So if we think about this, this is 3/7 times 3/7. So you multiply the numerators together, and you multiply the denominators together. So that's 9 over 49 plus 16 over 49 equals 1. When you guys could easily just type this into your calculator. If you guys wanted to do 3ABC7 times 3AB7, or if you wanted to do 3AB7 squared, fine with that. I'm just showing you what your calculator is doing, all right? I'm fine with you just putting this directly in your calculator, though. But since these have common denominators, you can add that together. So I get 25 over 49 equals 1. Is that true or false? False. So is this even a right triangle?
No.
So this is not a right triangle. So can it be a triple if it's not even a right triangle? No. No, so definitely not a triple. All right, so we're going to do the last page. Figure that's quick and easy enough. I figured the radical ones and the fraction ones are probably the ones you guys needed to see more than whole numbers. Okay, so we need to verify that this is a right triangle given coordinates. So to do this, the first thing you need to do is use the distance formula to find all 3 sides. That's why I'm writing it up here. It was part of your final, just to be aware. So your 3 sides are AB, BC, and AC. So Daniel, what is the change in x of AB? It's 5 and? We always keep it positive because distance is always positive. So that's a distance of 5 for x and a distance of 2 for y. Do you see that? So it's, even though it might be negative, you just always write it positive because distance is always positive. So we do 5 squared plus 2 squared. Lindsay, what is my change in x and change in y of BC?
Would be 10.
Be careful.
Well, not 10. 2.
There you go.
And
You're fine.
5.
Uh-huh.
Sorry, I did do this.
And that's okay. You don't need to apologize. That probably shouldn't have come out of your mouth. That was rude. Please apologize. Lindsay is now crying. Look at, she has tears coming down her eyes. So that's the square root of 29. Why am I not simplifying the square root of 29? Because I can't. Thank you. I hope that your notes help you tonight when you go to figure out what the heck you need to do here.
I know how to do this.
That's not the point that I'm trying to make here. I know, you're an angel, Logan. All right, Devin, changing X and changing Y of the last one there, AC.
Changing X is 3 and changing Y is U.
You were so sad. Is that even right? That's not 2 times 26. What am I doing? Is that 2 times 29?
Yeah.
Okay, so that can't be simplified. So just a really quick note here. If you can simplify any of your radicals, you need to. But to determine which side is your hypotenuse, look back at the before simplified radical. And just look at the numbers. So we have a 29, 29, and a 58. Which one is the biggest one? 58. So this is my C value when I go to check it. So the next thing we do is use the Pythagorean theorem. But you do need to make sure you know which one is your biggest side. You don't even have 3 sides done. You have, Ian, you have 1 side done and you're talking about a Chewy bar right now.
He lied to me. He said it was raisins when it was s'mores.
Oh, that's amazing.
Oh, I didn't want him to have it because it's
Hey. I know.
You just said this was the only one you don't understand.
Greg, keep him in line, please. You guys are really nice to each other, if you wanted to know. I think this is what happens when you guys have gone to school together for too long. So we do our factor trees. So I get 29 plus 29 equals 58. Is that a true statement? Is this a true statement? Yeah, so we have a right triangle.